Good evening, friends. Today we are discussing on dimensional analysis. Dimensional analysis is a method of dimensions. It is a mathematical technique used in research work for design and for conducting model tests. So in dimensional analysis we have two types of dimensions. One is the fundamental dimensions, the other one is secondary or the derived quantities. The fundamental dimensions we have three. So length is denoted by the symbol L, mass denoted by the symbol M, and the time denoted by the symbol T. Now coming to the secondary or the derived quantities. As the name suggests, these are the quantities which possess more than one fundamental dimension. For example, if you take velocity, it is the ratio of distance by time taken. Distance is L, time taken is T. So L by T we can write it as L T to the power of minus 1. Density is given as the ratio of mass by volume. Mass is in meters. Mass is given in kg, so that is m, and volume is the product of area into length. So area is in L square and length is in L, so it is L cube. So it is now m into L to the power of minus 3. Acceleration, it is given as the ratio of distance by time square, that is meter per second square. So meters, that is nothing but L and second square, so that is T to the power of 2. So I can write it as L T to the power of minus 2, and discharge can be given as Q is equal to A into V, that is the product of area into velocity. Area is given as meter square, that is length into breadth, that is L square, and velocity, so it is given as L T to the power of minus 1. Finally it can be written as L square into L, that is L cube T to the power of minus 1. Force, F is equal to M into A, mass into acceleration. Mass, that is M, capital M, into acceleration, that is L T to the power of minus 2. Modulus of velocity, if you take as an example E, so that is having the SI units of Newton per meter square. Newton in the sense it is force. So force is in turn written as mass into acceleration, that is M into L into T to the power of minus 2. So modulus of elasticity, that is in Newton per meter square. So Newton can be written as ml T to the power of minus 2 meter square, that is distance square. So that can be written as L square. Now 1L gets cancels with 1L here. So it is M 1 over L can be written as L to the power of minus 1 T to the power of minus 2. So these are taken as secondary or the derived quantities where we have used one or more of the fundamental dimensions, that is length L, mass M, and time T. Then dimensional homogeneity. What is dimensional homogeneity means? Homogeneous means same. It means the dimensions of each terms in any equation on both the sides are equal. That means if you take an equation with an equal sign, so LHS is equal to RHS, then such equation will be called as dimensionally homogeneous equation. If you take the velocity equation, for example, V is equal to square root of 2gh. So the dimensions of left hand side, that is velocity, it is distance by time taken. So it is distance is L, time taken is T. So So L divided by T, so that is L T to the power of minus 1. Then the dimensions of RHS, that is square root of 2gh. So 2 is a constant. So the units of this g, acceleration due to gravity, so that is meter per second square, that is meter, so that is nothing but L per second square, that is t square, into h. H is nothing but here it will be measured in terms of length only, so it is L. So it is square root of L square by t square, so it is finally L by t, so that is nothing but Lt to the power of minus 1. So LHS is also Lt to the power of minus 1. RHS is also Lt to the power of minus 1. So V is equal to square root of 2gh. It is dimensionally homogeneous equation. The methods what we are using in dimensional analysis is Rayleigh's method and Buckingham's method. So today we will take Rayleigh's method. So it is the method used for determining the expression for a variable which depends on maximum of 3 or 4 variables only. If an expression contains more than 4 variables, it is very cumbersome to use Rayleigh's method. Then we will go for Buckingham's pi theorem, that we will see later. So here we are taking a simple problem which is consisting of maximum of 3 to 4 variables. So the problem states like this: the time period t of a pendulum depends on the length of the pendulum, that is capital L, and acceleration due to gravity, that is g. So derive an expression for the time period. So now the time period is said that it is a function of length L and acceleration due to gravity, so that is g. Now t is proportional to L into g, and we are taking k as proportionality constant. So t is equal to k into L to the power of a, g to the power of b. If this particular quantity is depending on some other variable which is inversely proportional, then we'll write here a dash, and we are writing that variable which is inversely proportional to this. Then substituting dimensions on both sides. So time, it is capital T to the power of 1 is equal to k into L. We are writing as it is L to the power of a. G. So G is having the two fundamental quantities. So that is acceleration due to gravity, that is meter per second square. So that is nothing but L by t square, that we are writing it as L t to the power of minus 2, then to the power of b. Then equating the powers of these fundamental quantities L, m and t on both the sides. So here I don't have length on the left side, so it is L to the power of 0. I don't have mass also, it is m to the power of 0, and t to the power of 1 is equal to k into, it is now on the right side, L is having the power of a here and L is having the power of b. So it is L to the power of a into L to the power of b. So then it becomes L to the power of a plus b. M, we don't have anything on the right hand side, it is m to the power of 0. Then t is having the power of t to the power of minus 2 to the power of b. So it is finally t to the power of minus 2b. The powers of L, so it is 0 on the left hand side and a plus b on the right hand side. We don't have m on both left hand side and right hand side. And the power of t, on the left hand side it is having the power 1, and on the right hand side it is having the power of minus 2b. So minus 2b is equal to 1. So b is equal to minus half. Then we have a plus b is equal to 0. Substituting b as minus half, we are getting a is equal to half. Substituting these values a and b in time period equation. So it is t is equal to k into L to the power of a. So that is half, and g to the power of b. So that is minus half. So it is t is equal to k into square root of L by g. So this is the expression for the time period of a pendulum. Thank you.